Well, welcome back, my YouTubers. You 7th graders have been studying the distributive property for 3 weeks, and you've been doing this in order to isolate a variable and solve for what number, what value that variable is. Well, are there other options to using the distributive property if you're trying to isolate a variable? Yes, there are. See, because you guys have learned other academic vocabulary called inverse operations. Well, let's take a problem like this equation here where we're trying to find out what x is. If we're multiplying 3 times the quantity 2x plus 9 and it's equal to 51, what does this x have to be equal to? Well, we can figure that out by isolating the variable and solving for x. See, when we use the distributive property, we need to know that we're going to distribute, we're going to pass out the 3. We're going to distribute it to everything inside of the parenthesis. There are 2 different terms on the inside of this parenthesis. There's 2x and there's 9. So we're going to multiply the 3 times the 2x's plus we're going to multiply the 3 times the 9. Well, this is going to give us 2x's 3 times in a row, which is 6x's. And this is going to give us 3 times 9, 27. But the equation is still equal to 51. Well, now we've been studying two-step equations as well for more than 3 weeks. And we can isolate this variable after we're done using the distributive property. When we isolate the variable, we're trying to figure out what number x is equal to. But we want to figure out only what one of the x's is equal to. So the way we do that is we have to get rid of 27 by doing the inverse operation of adding 27. Well, let's take away 27 from 27. That's going to give you 0. 27 take away 27 is 0. Well, the only thing that would be left on the left side of the equal sign would be 6 times x. When you put a 6 in front of a variable x, this number is called the coefficient, and it's being multiplied by that variable. There's a number that if you multiply it by 6, it's going to equal 51, but you have to make this equation equal minus 27. See, if you took away 27 from the left side of the equation, you have to take it away from the right. So 51 take away 27 is equal to 24. Well, if I isolated the variable, I would only have one x, not 6 of them. So I'm going to divide 6x by 6, and this is going to give me 1x. This variable has been isolated, but I have to balance the equation. You see, when you took away 51 and 27, when you subtracted that 27 from the 51, you got 24. But you have to balance the equation by dividing the 24 by 6. Well, now a lot of you guys are like, well, yeah, Mr. Gonzalez, 24 divided by 6, one of those x's is equal to the number 4. Can we figure out that x is equal to 4 without using the distributive property, though? Yeah, because we know how to use inverse operations. See, before we multiplied by 3 using the distributive property. But what would be the opposite of multiplying by 3? Well, of course, it would be dividing by 3. So what if we divided 3 by 3 and we balanced the equation? Well, this is going to give you 1 times 2x plus 9 equals 17, because 51 divided by 3 is 17. But, Mr. Gonzalez, I didn't want to use the distributive property, and I still have a number. I have the number 1 in front of that parenthesis. Well, here's the great thing about multiplying by 1. It doesn't change anything. You see, what's 1 times a million? It's a million. What's 1 times 0? It's 0. What's 1 times negative 12? It's negative 12. You're not going to change a number by multiplying it by 1. So what's 1 times 2x plus 9? Well, you're not going to change 2x plus 9 because 1 times 2x plus 9 is 2x plus 9. And this is still equal to the equation 17. If I isolate the variable by doing the opposite of adding 9, which is subtracting 9, and then I balance the equation, which means I have to take away 9 from the 17. This is going to give me 2x is equal to 8. Well, you guys already know that the opposite of multiplying by 2 would be dividing by 2 and then balancing the equation. 2x's divided by 2 is 1x, and 8 divided by 2 is still 4. See, you can use the second method and still get the same answer. Now, if you guys think you guys actually got this down, I've got another equation for you that I want you to practice this second method on. I want you guys to see if you guys can go ahead and solve this equation. And I'm going to go ahead and write it with you. And I don't want you to use the distributive property. I want you to see if you can solve and isolate this variable without the distributive property. Now, I know some of you guys are like, I don't know, Mr. Gonzalez, I'll give it a try. I want you to pause the video right now. I want you to write this equation down and try to use this new method here, this second option, and see if you guys can figure out what m is. When you're done, unpause the video and then check your answer with me. Okay, so I know you guys have unpaused the video, and now you're probably going ahead and saying, okay, I got an answer, but I need to check if it's correct. Well, let's check to see if you did it correctly. Let me go ahead and divide 5 by 5. You see, that's what I did before. I divided 3 by 3. But this time, I'm going to divide 5 by 5. Now I'm going to balance the equation and divide 135 by 5. This is going to give me 1 times 3m plus 6. Well, once again, we already knew if you multiplied anything by 1, you weren't going to change 3m plus 6. But what's 135 divided by 5? Well, this is going to give you the number 27. If you isolated the variable correctly, you subtracted 6, then balanced the equation, and then you got 3 times m equals 21. Now, some of you guys already know that m is equal to 7 because you know what it means when you put a 3 in front of a variable m. It means to multiply. Well, let's divide by 3, and this gives us 1m. And if you balance the equation, 21 divided by 3 is equal to 7. Now, if you want to, you could use the distributive property, and you could still get that m is equal to 7. This is hopefully going to help you out, this new other option that you can use. This other option might help you in the future. Have a good one, YouTubers, and I'll see you guys next week. Bye-bye for now.